Em ơi, gọi dây nhỏ luôn. Dạ chắc mình bắt đầu chắc em đọc luôn cái nhóm đề tài thứ nhất của báo cáo luôn nha thầy Đức, được không chứ?
Dạ, vâng, cảm ơn thầy.
Dạ. Thì kính chào quý thầy cô trong hội đồng và các em sinh viên. Ha. Thì cái đề tài đầu tiên của buổi báo cáo hôm nay là với tên là Design and Implementation of a Carton Box Cutting Machine using 3D alignment technique for optimizing packaging size. Thì cái đề tài này thực hiện gồm có 4 sinh viên. Thứ nhất là sinh viên Nguyễn Hồ Duy, mã số là 171461010, sinh viên Nguyễn Hữu Hân 1714630, sinh viên Lê Quang Nhật 171464046, sinh viên Phan Thị Quỳnh Trân 171466068. Rồi mời các bạn báo cáo ạ. Và giúp hướng dẫn là thầy Thạc sĩ Phạm Bạch Dương ạ.
Yeah. Good morning, everyone. Welcome everyone to join the presentation of our team today. We are the team Anti-Fish, coming from the University of Technology and Education of Ho Chi Minh City. Today is our graduation project, and our team topic is design and implementation of carton box cutting machine with 3D alignment technique for optimizing packaging size. Our advisor is Mr. Phạm Bạch Dương, and we have 4 members. My name is Hưng, and my friends Trân, Nhật, and Duy. So here we come to the first slide of our presentation, the content. We have 5 main sessions on the screen you are seeing. Here we come to the session 1, the overview session. Now I'm going to explain about the topic choosing reason. As you already know that in this pandemic COVID-19, lots of people got demand to buy something online. So the packaging was always a problem to occur in our life. To know this, Anti-Fish team decided to choose this topic because we want to solving packaging problems. So what are those packaging problems? After many discussion and online survey, that Anti-Fish team decided to choose 4 main packaging problem on the screen that you are seeing. And we have a problems, we must have a solution. Anti-Fish team decided to make a solution for the packaging problems. We're going to make a machine, package box making machine, in using the 3D, the cross-wire rapid system, the laser, and learning theory from 3D scanner. At first, we come to the session 2, the machine inputs and outputs. Now I'm going to show you guys about the machine inputs. Our machine inputs divided into 2 parts. The manual parts and automatic part is showing on the screen. Both of them, we just have only one difference. The automatic part doesn't need the object dimension. It just only need the object because already included with the 3D alignment system. It can measuring the dimension of the object by itself. So here we come to the machine outputs. Our machine outputs is an unfolding paper box with accurate dimension at exactly what I'm showing on the screen. And this is the end of the session 2. Here's come to the session 3, design implementation, our most important session. On the screen, our machine block diagram. The block diagrams makes people to easier for image out the setup and the position of each component. The green line is present for electrical line, red line present for signal line, and black line present for mechanical line. The blue dashed line over there present for 3D measuring area. So here we come to the mechanical design. On the screen, you are seeing the 3D drawing. I use the frame of the machine to make from the aluminum profile, got a dimension of 30 multiplied 30 millimeters. And this is the overall dimension, the assembly of the frame of the mechanical. Our mechanical divided into 2 parts, the laser CNC cutting system and 3D alignment system. First, I will come with the laser CNC cutting system. And this is our mechanical parting list, showing you guys the position and how we're setting up the component of mechanical. And we use the cross-wire driver system. We just only need two motors, the X1 and Y1, to control the 30 watts laser diode. And here we come to the part 2 of mechanical, the 3D alignment system. Showing on the screen are our mechanical parting list. And this is how we're going to calculate out the dimension of an object. We just only need the mass position, the distance of the X, Y, and Z of our measuring area to minus the X, Y, and Z of position of the proximity sensor. The result is going to be the X, Y, and Z value. That value is also the length, width, and height of the object that we want to calculate, we want to measuring out. And on the screen now is a comparison between the implementation between the render image on the software and the reality image that we already create our machine. So basing on this mechanical frame, mechanical machine that Mr. Nguyễn Hồ Di gonna show you guys about the motor, stepper motor selection and calculation.
Bật mic lên, bật mic.
Sorry. Good morning, everyone. As Mr. Hưng just mentioned about a general design of machine, in this session, I will present how we select the motor for the machine, include the motor for CNC laser cutting system and 3D alignment system. We select the stepper motor because it is commonly used in precise control machines. The standard of motor selection is given on the slide. The selection must satisfy to these criteria. The power of machine, inertial moment, the torque and the speed of machine must be less than the maximum parameter of motor. On the motor selection for CNC laser cutting system, we select the stepper motor NEMA 17 with the series given on the table. Compare the parameters of motor in red number to parameter what cutting system needs in black number. This stepper motor is approved to use. On the motor selection for 3 alignments, the standard for selection is similar to the previous slide, although there are some differences in the series of stepper motors because the load in 3 alignment for X and Y axis is smaller than that of cutting system. However, the Z axis needs more torque to lift, so we decide to use a more powerful motor. The series of motor is also given on the table. To continue the chapter design and implementation, I will move on to the control system. But first, we can see the list of electrical devices that contribute on our operation of machine. In order to understand how these things connect and work together, Mr. Nhật will represent our team to share it. Thank you.
Okay. Hello, everybody. Keep on session design and implementation based on the electrical component. Mr. Z talked in previous. I will present about the control system of our machines. The control system divided into 3 parts: the wiring diagram for CNC laser cutting, 3D alignment, and the manual mode system. First, we look at the CNC laser cutting. The whole machines were powered by the DC supplier and controlled by Runo Mega, assembled with the CNC module RAM BSV1. The MCU would receive the command from the LCD controller to control the stepper motor in order to move the diode laser. Next, on the slide, we had both the 3D alignment and the manual system wiring diagram. Each system had a different MCU to control an Uno Mega and Uno. For 3D alignment system, the MCU will control the motor sensor, and the automatic LCD will show the measurement result. For the manual system, the manual LCD will show the dimension information which were tied into the keypad. For LCD will show the result, a number of Zico files. In order to run Zico files, we use the firmware modeling V1 and modify under Arduino IDE software to fit with our machine function, then upload into the main MCU. In order to understand clearly about how our machine works, I would like to present about the flowchart of the machines. Our machine has to move with our automatic and manual modes. For the complex object, we use the manual mode. First, user press the manual on button, then input the value, length, width, and height, and quantity of the object that user wants into the keypad. If the object had a cube or cylindrical shape, user can put it into the 3D alignment. Also, the automatic mode and press the automatic on button, then the automatic measurement will start. Both the automatic and manual modes have the same purpose to determine the dimension of the object. Based on this dimension, the LCD will show the number of Z code files. Finally, user have to select the Z code files in the library of the main LCD controller, then press the start button. The operation will happen following the required Z code files. During reset operations, if there is any problem, user can press the reset button, then the system will be restart. During the end of section 3, design and implementation continue with Ms. Trân. We talk about the experiment and analysis.
Hello everyone. After Mr. Ye finished the section 3, design and implementation, now I will present about the section 4, the experiment result. On the screen now are two tables, the needs of our machine table on the left and the matrix table on the right. The left represents for the requirement of our product. It was the arranged following the important right from upside down. The matrix represents for the measurement way of the need. Each matrix has their own unit. There are two types of the matrix, the direct and indirect. The next slide. This slide showing the summary table of needs and matrix. The blue color represents for the indirect matrix, and the yellow one represents for the direct matrix. A need must have at least one direct matrix or two indirect matrices. Let's see our most important table, the specification table. Just look at this table. Everyone can know any information of our machine. For example, look at error number 10, the average yield of the machine. The ID value is the parameter that anti-system already calculate, and the marginal value are the tolerance from that ID value. In here, we have the range of the average yield runs from 46 to 48 boxes per hour. There are three types of specification: basic, additional, and advanced. From the next slide, from the parameter of the previous slide, the parameter came from our experiment table with at least 10 times testing for each parameter. For example, the biggest object measuring time table. First test, the measure value is 35.2 to 28 seconds, match 94.4% to compare with the ID value. The next example, the biggest box cutting time table. Testing number 3, the measure value is 227.84 seconds, match 87.2% to compare with the ID value. And here are some pictures of our result. And now is the operation video of our machine.
Okay, and this was the end of our video. So after 3 months trying to work together, we're learning so much knowledge and lesson. This is going to be our precious things for our engineering journey in the future. Our NGHIểP team want to give our special thanks to our advisor, Mr. Phạm Bạch Dương. Until that our machine is still have some limitation, but we're going to upgrade it in the future. And thank you so many lecturer, professor, PhD master to come to attend in the presentation of us today. Once again, thank you very much. Dạ, đó là hết kết thúc phần trình bày của tụi em. Cảm ơn.
Rồi, cảm ơn phần báo cáo của tụi em nha. Đây kính mời, chắc mời thầy Đức.
Thầy Tròn có thể đọc cái nhận xét của giải phiên bản biện luôn ha, có gì copy sang. Thầy Tròn
Rồi, vậy bây giờ thầy sẽ copy cái câu hỏi trước nha, rồi thầy sẽ đọc luôn cái phần nhận xét của giáo viên phản biện nha. Đây cái câu hỏi thầy sẽ bỏ lên group cái câu hỏi của nhóm 1 nha, để coi giúp thầy. Rồi bây giờ xin phép hội đồng và các em xin được đọc cái nhận xét của giáo viên phản biện. Thì các nội dung trên thì các tên đề tài rồi sinh viên thì chắc xin phép bỏ qua, lượt qua cho nhanh ạ. Bây giờ mình đi vào cái ý kiến nhận xét. Đầu tiên là về cái kết cấu và cách thức trình bày đồ án tốt nghiệp. Thì đầy đủ các đề mục yêu cầu của khoa đưa ra, sai nhiều lỗi trong canh lề đề mục biểu bản, còn sai nhiều lỗi về ngữ pháp tiếng Anh, các đoạn còn rời rạc, thiếu tính liên kết, từ ngữ còn dùng mang tính cảm tính. Rồi về cái nội dung của nội dung đồ án thì đề tài có tính ứng dụng cao trong thực tiễn. Rồi về kết quả đạt được, hoàn thành lắp ráp mô hình cơ khí, hoàn thành phần hệ thống điện, hoàn thành chương trình điều khiển, vận hành và chạy thử. Về nhận xét thì thiếu sót phần cơ sở thiết kế, tại sao chọn hệ thống điều khiển vòng hở kín, nhóm chỉ liệt kê và đi thẳng vào hệ thống điều khiển vòng hở open loop. Phần trình bày lưu đồ flowchart, block diagram chưa đúng. Các hình ảnh cần được cung cấp bản quyền tác giả, một số hình ảnh chưa được chú thích. Rồi một cái nhận xét nữa là không có bản vẽ lắp và các bản vẽ chi tiết đều không có dung sai kỹ thuật. Đó là phần nhận xét ạ. Và câu hỏi thì có hai câu hỏi A và B thì thầy cũng đã gửi lên nhóm rồi. Câu hỏi đầu tiên là câu A. Trong mục 3.1 trang 25, nhóm đưa ra danh sách log listing, nó mang ý nghĩa gì? Câu 2 là câu B á. Tên đề tài đề cập đến tối ưu optimizing, nhóm làm rõ chữ tối ưu trong việc tính toán kích thước cho minh chứng. Xin hết ạ. Các bạn có nghe rõ câu hỏi với lại cái phần nhận xét chưa ạ?
Dạ có ạ.
Rồi.
Dạ, tụi em trả lời luôn ạ. Dạ, tụi em trả lời luôn hay sao?
Rồi tụi em trả lời luôn.
Yeah. According to the session 3.1 of the page 25, our group is just to present the block listing. This is the accessory for the block diagram. The block diagram that includes lots of blocks. For example, like the motor X1 and motor Y1, the laser diode, and the source of power. It's all just the block and the name, the shortcut name. So our team present the blocks listing just to make an explanation to more details for the block diagram. Or for example, what is the stepper motor X1 and what is the function of it? And what is the function of a source of power, and how many voltage, and what kind of power is it, the DC or AC, And this is the function and the meanings of the block listing. We want to explanation and make a clearer view for the block diagram. And for the question B, our machine name is just the demands were basing on the optimizing. And I want to make clearer for the optimizing in calculate the object size. Optimizing here is which mean you can, for example, like many times lots of people just booking something online and they receive a box with an object. It doesn't fit the dimension to each other. A box too big and the object is too small or something, and this can cause a lot of problems. So our team optimizing here, which means we reduce the most we can the vacancy between the object and the box to decrease the broken rate or the maybe the wrap. We can reduce the wrap cover and the paper using. And this optimizing, which means we do our best to create a box to fit with the object. And in the calculate the object that it just you use the machine already used. As you already know that in the market, lots of sellers have to worrying about considering box size. They have to choose a box every month before they want to get a package of something. Like I'm a seller and I'm selling a lot of things. I'm selling perfume, I'm selling MCU, I'm selling stepper motors, but I don't know how much stepper motor and how much MCU I'm going to sell a month. So what kind of dimension of the custom box that I have to book, I don't know. It's just basing on experience. And our machine is just optimized. We can just only take it home and it's calculate the dimension of the object that you need. It just only create a box that fit with your demands. You don't need to go anywhere to buy something. You just only need a big, huge of raw paper. And that was my answer of the two questions A and B.
Okay, thank you. Any question from the committee?
Okay, I have one question, or maybe two. Did you take the question into consideration? For example, if you only have the solution you have is for only a single object, right? You don't put multiple objects into the box, right?
It's basing on the shape. It's basing on the shape. It's just not just only one object. You can put 3 objects if you want, but it's basing on the shape and it's calculate the biggest dimension.
Okay, because as what I saw on the video, yes. The measuring system you're using is just to detect the outer edge of the whole thing.
Yes, yes.
I mean, so for example, if you want to put multiple objects into the measuring system, you have the big box, you have the small box, yeah. And you know, it's maybe different. And also the shape of the box is also the shape of the objects is different, right?
Okay, so in here I have some explanation that I use the pen software for easier to know. For example, like this, I want to share in the screen a little bit. You see on the screen that I just draw. For example, this is 3 different objects with 3 different dimensions. Okay. We already mentioned that the limitation of our machine is just we just can only measuring the object that we got the shape of cylindrical and curved. And here, our machine can create a box like this. is include all of this.
Okay. How about the cushion? I mean the foam that separate put in the middle between the object and the box.
Excuse
Did
me.
you consider the cushion? I mean, you have the box, right?
Yes, yes.
And you have the object small inside.
Yes.
And the space around the object is the space there where you put the cushion foam inside to protect the object. No? So your cardboard box is not. I mean, it's too thin. You cannot protect the whole thing inside, right?
We already let a little space for about 3 centimeters for wrapping some tape or paper to cover some kind of easy to broken object, and that's also one of our limitation. We just cannot adjust the space between the object and the box. It just freezes for 3 millicentimeters.
Okay. Okay. And second question I want to ask is when you put the cardboard onto the surface of the laser cutter.
Yes.
Okay. And as I can say that you have to flatten the cardboard first.
Yes.
Because in case if it's not flat, the laser cutter the distance between the laser cutter and the surface is different.
Yes.
It's not even with the whole system. Okay. So it may burn the cardboard, I think. Did you think about this? Maybe it could be too dangerous to use laser to cut the cardboard.
Okay, we already think about this before. The first step is because of the power of the laser is quite strong. So even though that you put the flat of the cardboard is not flat enough, but it still can burn as our expectation. And about the dangerous or not, we already do the cover. The wind is just cannot affect into the cardboard, and the cardboard is weight enough to stick into the blade of our machine. As you seeing on the video, we use just a little thin of cardboard, but it still cannot move because it's already stick into the blade of our machine. And maybe we will upgrade to some mechanical system that can hold tight for cardboard. And this may reduce the dangerous rate.
Okay, thank you very much.
Yes.
Good morning, committee member and the student. So I have some comment and questions for you guys in these pieces. The first one is comments. So you guys have good presentation, confident and fluent. That's a congratulations, you guys. And the second is the topic is realistic, really realistic, and the products can apply to improve productivities. And question, there are so many similar products that would have been commercialized. What are advantages of your solution in comparison with the other previous products? This is the first question. And the second question is, why do you choose a stepper motor instead of DC servo motor? Because as I know, DC stepper motor, DC motor is better than a stepper motor. So, okay, you can answer some of my question. Thank you.
Okay, I'm gonna answer first.
Okay. Now, I need other member answer because there's one person that answer last time until now. So how about another member?
Okay, so Mr. Nguyễn Hữu Di, okay, my teammate is gonna answer this question.
Good morning, everyone. I am Nguyễn Hữu Di. I will answer the second answer. The reason why we choose step motor because based on our observations, most of precise control in the low level on use step motor because technique advantages of precise control because the step motor divided into step that make the motion control become more precise. So that's the reason why we choose step motor based on the price aspect and easy to control and a valuable library to support this.
So I think this is an unacceptable reason. So why do I say that? So because you are talking about the precise, it means that the accuracy of step motor is better than DC motor. So this is unacceptable. So because the DC motor, you can use a position control, velocity control by using the BID and the other control algorithm. I think it's better. Do you understand what I mean?
Yeah, well, but in our limitation and knowledge, so it's really hard to control a DC motor well because when we use DC motor in lower level, we also make some problem like lost the torque. That make the control error. So that is the reason why we choose step motor to increase the torque stable during operation.
Okay, so I have a very small question for you guys. Do you use open source in these projects, or you are programming, you are coding, your own coding?
They are to part the part for cutting machine because it's really hard to use chirL or NC file library. So we must find on the internet and the firmware that support the operation was stable.
So it means that you are using the open source code and you added something. Is this right?
Yeah, yes, but in 3D alignment we code by ourselves because there's no library support on operations.
Okay, so I think this is the reason you choose stepper motor. That's the reason you choose stepper motor. So I think you should tell the truth. Yes. Okay.
Yeah.
Okay. How about the first question?
Questions. Because we just do a lot of survey. In our machine, we can provide multi-dimension and multi-style of box compared to the other side, the other place. That's just important in the amount, in quantity. And we provide multi-quality in the box and in the style to satisfy multi-function for multi-job, multi-aspect, especially on the machine outside tend to industrial thinking, industrial size, and our machine tend to family company, family business organizations.
So do you understand what I question? So what my question? So I'm asking you. So what are advantages of your machine in comparison with the other one? So it means that I'm asking you about technique and economy or something like that. So what is your solution is better than other one?
About our solutions, we provide a tool for measuring some object, although it didn't complete. So in the future, we hope that we will apply more advanced technology to increase the quality of measurement and increase the ability to measure all of things. And that's and we will upgrade the automatic control between these procedure that make it more automatically. That is our advantages compared to the other ones. And we hope that our machine is cheaper than the others.
Okay. Okay. there's one more small question. So, could you interpret the weight of online measuring objects with arbitrary shape? So I see in your thesis, you are using a proximity sensor to measure the dimension of the object. So how can you use this sensor to measure arbitrary shape of the objects? Because the arbitrary shape, they have nearest point, they have furthest point. So how can you measure? By using this sensor. Do you understand what I mean?
Yes, I understand what you mean.
Okay.
I answer your questions. Your question is a limitation of our project. Our project can be measurement the object have the shape cube or circular bottom, and if you want to measure the complex object, we can improve in the future. This is our limitation.
Okay, so I think you should put this limitation in the future work. Is it better?
Yeah.
Okay. Okay. Thank you, committee member, and thank you, student.
Thank you, Prof. I have a few comments because I think your report is not well prepared. There are too many pictures, very little description. For example, in the first chapter, in the chapter 1, there is no project objective, so I don't know what you are going to do. In the chapter 2 about literature review, you should review about the box making machine, not about the motor, step motor, not about the CMM. It's not related to the project. So you should focus on the box making machine, review about it, review the advantages and review the disadvantages. Okay. In the chapter 3, I think half of the chapter 3 is pictures without any description. I think this is a big problem. You need to revise the report carefully. And in the references, there are only 4 references for the whole project. And 3 of them is from some website. It's not a reliable source. So I think you should discuss with your prof, the supervisor, and revise the report before you submit it again. Okay, thank you. I think we can move on to the second project.
Xin chào quý thầy cô, vậy cho mình rút lại các ý kiến chỉnh sửa của cái đề tài này trong thành viên hội đồng.
Wait a minute. I have a comment. Okay, in drawing, there are no tolerance in the part drawing, and principle of drawing should be considered. For example, the center line is not present in the drawing, and the dimension is taken should be taken carefully. Okay, just only about the drawing problem. Do you hear me?
Yes.
Okay, you got my idea?
Yeah.
Yes, I will.
Okay, you just take a check and rewrite your drawing. Okay, engineering drawing about tolerance. You know tolerance?
Yes.
And the principle of drawing, for example, the center line should be present in the circle, and the dimension should be taken carefully. Okay. Oh, that's all.
Got it. Thank you very much.
Thank you.
Thì chắc mình qua cái thứ hai rồi để mình tổng kết lại rồi cuối buổi rồi mình ghi lên, mình sẽ trình chiếu luôn các ý kiến chỉnh sửa vậy. Được không thầy Đức? Để cuối buổi rồi mình sẽ trình chiếu luôn lần vậy. Quý thầy trong hội đồng thấy chạy được vậy?
Dạ em thấy ok thầy. Để cuối buổi rồi trình bày hết với thành viên hội đồng.
Rồi cảm ơn. Thì xin mời đề tài tiếp theo nha các bạn. Mời các bạn đề tài tiếp theo. Thì các bạn, đề tài tiếp theo là đề tài mang tên là Research and Improvement of a Heating Oven for more inclusive plastic type manufacturing with a SCADA system. Sinh viên thực hiện là sinh viên Bùi Phương Bắc 171460002, sinh viên Lê Đình Dũng 171460007, sinh viên Nguyễn Thị Ngọc Yến 171460077. Giáo viên hướng dẫn là thầy thạc sĩ Phạm Bạch Dương. Xin mời các em bắt đầu. Các em có nghe rõ không ạ?
Có nghe.
Rồi.
Như bạn Yến gặp trục trặc cho nên là em xin phép share màn hình.
Rồi, tụi em cứ tiến hành đi nha.
Good morning, everybody, and welcome to our presentation. Let me introduce myself. My name is Ngọc Yến. Two members are the Phương Bắc and Linh Dũng. Today, we are here to present to you about graduation projects, research and improvement of a heating oven formal.
Sorry. So, seem to be your picture do not display in the screen. Is this right?
So sorry, because my camera of my pen has a problem. So
so I do not see the face of the presenter.
Camera bị rủi rồi thầy không?
Rồi bên chỗ thầy Đức, cái camera bạn không có thì chắc là mình báo cáo luôn thầy Đức.
Mình cứ cho các bạn báo cáo đi, tại vì cái trục trặc là cái chuyện mà chắc là cũng sẽ xảy ra nhiều trong cái hội đồng. Tiếp tục đi các em.
Yes.
Em tắt camera bật lại thử đi Yến.
Đúng không có cái bật thầy ơi. Để tôi xem cho.
Chắc không được rồi, thôi em báo cáo luôn đi.
The name of project is Research and Improvement of a Heating Oven Formal in Liquid Plastic Type Manufacturing with SCADA System. Sponsored by KHÓA Company and accompanying us advisor Phạm Bạch Dương. We divided the presentation in four main parts. Firstly, in the introduction, we're going to focus on motivation, review, problem, and scope. Then, we will look at the methods, include approach, experiment, and analysis. Next, we're going to show the result, the video and figure and conclusion finally. As you are unaware, today liquid plastic manufacturing sector is extremely expensive, such as LUient, Kltn, and KHÓA are which have a cheap production cost. During the research process, we found the limitation of the available on the market. That is the cost to our machine is too expensive. The machine is too large and take up a lot of space. They are enough. The power consumption is high, and the machine makes a lot of noise during operation. Next, you can see in this picture, this is a machine that has been researched and designed by previous brother, but there is not enough time to experiment and verify the accuracy and stability of the PI controller. In addition, we found that the setting of packing of the time is limited. The cooling system is not optimized, and there is no SCADA system for easy operate and monitoring. Our subject scope experiment with the packing mode that we have chosen to back the PI controller. At the right time, settling time, and overshoot parameter correctly calculate, and optimize cooler control method, and change the backing time setting method, and make a machine easier to monitor and operate. After the research process, to achieve the scope of the project, we offer the following solution. Initially, the cooling system was controlled by temperature controller MC701. We found that MC701 puts pressure on the lock because the cooler has to turn on and off with constant frequency. Is harmful to the system. So we use the iteration in the logo for easy control. In the old method, we had they use the toggle switch to set the time. However, they roll back that only to fix the timeline. If you want to change the setup time, you have to rewrite the code. Therefore, we use the time relay instead. We want to change the packing time, we can change it directly on the timer relay. To make the machine easy to operation and monitor, we designed the SCADA system on the HMI screen and use factory I/O software to simulate the system. Now, Bác is going to continue present with experiment and analysis.
Now, I will represent my team to talk about the design of the machine. First is the block diagram of the heating system of the machine. We use two suppliers, 24 voltage and 220 voltage. With 220 voltage, it will supply for the oven or the measure coil. 24 voltage will supply for controller and all sensors. The block diagram divided into two sides, the left and the right. And the function of the left is the same with the right. Next is the control design of cooling system. In the previous version of the machine, they used the temperature controller MC701, but as Bit Inc. said, it's not optimized for the machines because of two reasons. First, it cannot send the data of temperature of water to SCADA system. Second is it uses PID to control the cooling system. It will make equipment of cooling system get rich because the frequencies of on and off is very high. So that we change to logo BC to control the cooling system based on the threshold voltage. As we can see on the diagram, there are two limits, on and off, with Ix is temperature of water. When the temperature of water is higher than on limit, the cooling system will be set to 1, and when it goes down under off limit, the cooling system will be set back to the 0. And beside that, the on and off limit can be set by the user directly on HMI. Next is operation of the machine. First, we have to set the timer for desired time, and then push the button to open the oven door and put the mold into the oven door. After that, push again the button to close. At that time, the timer will start countdown, and after finish countdown, the oven door will open and the pull-down cylinder will push out the mold out to the water tank. After 5 seconds, the oven door and the pull-down cylinder will back to the initial position. The operation of the left oven is the same with the right oven. And next is electrical design of the machine. We use one logo PLC and 2 extended modules to control on system of the machine. And next is SCADA design of the machine. We use XMI with tech and build on Easy Builder software based on input, output, the temperature of water, and the oven. Beside that, it can display the time countdown of the timer. And next is 2 tables show the way we check the stability of PI controller of left oven and right oven after 30 minutes. The ideal value, temperature, and the marginal value will follow the require of the company, and the error stay have to under 3%. So from the table, we can see that the PI controller of the machine is usable. And next is a table show the way we find the expecting time of the product when packing. We base on 4 criteria: unburned, the surface, elasticity, and strength. All of these will be evaluated by eyes. And after all, we find the expecting time of the left oven is 8 minutes. The right oven is 2 minutes. And next, Nhóm will continue to talk about the result of the project.
Hello everyone, I will continue present about the result part. You can see this is the figure, so the overall view of the machine. See the control panel, and I will go to this part a bit later. The water tray is used to cool the mold after baking. The machine has 2 ovens, lower oven and upper oven. Lower oven is used to be on the bottom of the mold, and upper oven is opposite. We have 2 buttons you can press to open or close the oven door. The cooling system including a radiating fan, a pump, and water filter. And finally, this is the outlet of water tray. Next, this is a new control panel after being remade, including a power switch due to start power system for the machine, directly powering for logo HMI. The control section including logo, expansion module, analog output module, and HMI screen. We have 2 relay timers due to set the baking time. Beside are 2 switches due to turn on or turn off through oven. And finally, we have 3 indicator lights to show the status of the machine and through oven. Next, we design SCADA through HMI screen and use factory I/O to simulation. HMI screen shows some information like the temperature, baking time, status through oven. And below are 2 buttons you can press directly on HMI screen to turn to open or close the oven door. The cooling system, we can see two values. Upper limit value is used to activate, and lower limit is used to turn off the cooling system. And another is current water temperature in the water tray. With factory I/O software, we use to simulation the machine with corresponding components like water tray, cylinder to open or close the oven door, product injection cylinder, indicator light, power switch, and button. This makes it easy to collect the data and monitoring. And next, this is the product after tested with different time. You can see initially the product do not meet the evaluation criteria, such as flammability, durability, elasticity, and have a poor surface gloss. But in the end, we found the right baking time to have the high quality product after baking. And now I will show the video. So after periods of research and improvement, we come to the conclusion. In terms of achievement, the machine has a stable PI controller, so the product is high quality after baking. We easy to set up the baking time before we start. We easy to data collection and monitor. We optimize the cooling methods, reduce the damage to the cooling system. About the limitation and future work, this machine needs to replace the electric box to easy maintenance and automate the process of putting the mold into the oven. And next, I will show the relay letter, quality inspection report from the company. So in the end, we would like to express thank Mr. Phạm Bạch Dương for this support and help during doing this project, and KHÓA company sponsors my team. So this is my presentation of my team. Thanks for watching.
Chắc sau đây thay mặt hội đồng thầy xin đọc qua nhận xét của giáo viên phản biện ạ. Chắc mình đọc luôn, chắc mình đọc luôn nha các thầy cô trong hội đồng ạ.
Thầy chọn cứ đọc đi ạ. Cứ sau khi sinh viên kết thúc xong thầy chọn cứ đọc đi ạ.
Rồi sau đây thầy xin lướt qua, bỏ qua những cái nội dung về tên, về tự tên đề tài nha, thầy đi thẳng vào nhận xét nha. Ý kiến nhận xét. Thứ nhất là về cái kết cấu, cách thức trình bày của đồ án tốt nghiệp. Đề tài có kết cấu hợp lý, phù hợp yêu cầu của đồ án tốt nghiệp. Về nội dung đồ án, đề tài này tập trung thiết kế hệ thống SCADA để điều khiển nhiệt độ lò nung cho khuôn đúc sản phẩm từ nhựa lỏng. Hệ thống điều khiển sử dụng PLC logo, SMI và các module mở rộng cho PLC. Thuật toán điều khiển BI dựa trên kỹ thuật chirL được sử dụng để xác định các hệ số KB, KI cho bộ điều khiển. Hiệu quả của hệ thống gia nhiệt được kiểm chứng bằng các thí nghiệm. Về kết quả đạt được, thứ nhất, hệ thống SCADA điều khiển bằng PLC. Thứ hai, kết quả thí nghiệm nung sản phẩm bằng lò nung đã chế tạo. Thứ ba, bộ bản vẽ cơ khí gia công. Tuy nhiên, dường như phần cơ khí được sử dụng từ kết quả của đề tài trước. Tên của người vẽ trong các bản vẽ không phải là sinh viên trong nhóm đồ án tốt nghiệp này. Về phần những thiếu sót và tồn tại của đồ án tốt nghiệp, thì cuốn báo cáo thuyết minh chưa có phần mục lục. Về câu hỏi thì có 2 cái câu hỏi thầy cũng đã gửi trên cái trang lên trên cái group Zalo rồi đó. Thầy xin được phép đọc qua. Câu hỏi thứ nhất: Why is the furnace designed with 2 chambers in 2 different working modes? Is it designed for sittering different products or for processing the same product with different heat treatment steps? The second question is, assuming that a product needs to be heat treated through 2 steps with different parameters for each step, temperature, time, with the current machine, how can you handle heat loss if you have to take the product out, run one chamber and put it into the other? Can automation for such a product process be implemented and how? Rồi, xin mời các bạn.
Xin phép thầy cho nhóm em 1 đến 2 phút để thảo luận.
Thầy góp ý một chút về các cái nhóm trình bày sau là chúng ta cố gắng speed up cái tốc độ trình bày của mình lên chút ha. Ví dụ như 2 nhóm đầu thì 2 nhóm đầu tiên hồi hộp thì các thầy để bọn em nói lố thời gian chút xíu, nhưng mấy nhóm sau chúng ta cố gắng là trong vòng 15 phút thôi, 15 phút chúng ta trình bày nó xong.
Các bạn ở trong lúc nhóm này thảo luận, thầy cũng xin nói thêm, thông báo thêm các bạn là trong cái đề tài các bạn có cái phần cộng điểm cho các nhóm mà có các bài báo, có các sản phẩm mà liên quan đến đề tài. Thầy xin phép được đọc qua các nội dung mà các bạn sẽ được cộng điểm. Nếu có thì các bạn chuẩn bị minh chứng nha. Về cái thứ nhất là sinh viên có tham gia các cuộc thi sân chơi khoa học có giải thưởng. Thứ hai là sinh viên có bài báo khoa học trong và ngoài nước. Và thứ ba là có điểm xác nhận chuyển giao công nghệ. Nhưng mà những cái vấn đề này là phải liên quan đến đề tài của các bạn nha các bạn.
Em xin trả lời câu hỏi số 1 ạ. Why is this furnace designed with 2 chambers in 2 different working modes? Because with the plastic product, we have to in the lab oven, we have to bake from the low to the upper lower to the upper, because the product need to bake. Because the product in the left oven, we have to bake the product longer than the right oven, because
Can you answer the question? If you cannot, we can move on to the next question.
Yeah. Wait me a few seconds. Because when you take the ink because the ink have to back to become a black stack, so the leftover will back from the lower to the upper, and it will make the ink become rare, but not rare, but it's not. It's a wood product, so that we have to change to the right oven to back from the upper to the lower, and then and then the ink will be perfect baking, so that it have to design for two different mode, and that's my answer for the question 1.
I will continue answer the question 2 because we need two steps with different parameter for temperature time, because the product is based on a mole, and the mole is fixed. But in the second, the product is directly exposed to the heat, and in the first oven, the product is at most cooked. And our question, can automate for such a product process be implemented, and how it can, but it's very difficult because the size of what to say is very small. This is my answer for question 2.
I will add some idea from the question 1 in the second idea of the question. It used for the one product, not for two product. If in the left oven we bake the A product, and so that we have to put the A product to the right oven to finish the loop of the baking. If we bake A product in left oven and we put the B product in the right oven, it's not effective. It's not work. That's my finished answer.
Okay, thank you for the answer. Any question from the committee?
I have one question. Did you guys measure the temperature of the vicinity of the furnace? Because you are using like a standard pneumatic equipment, so the maximum temperature of the operation is 80 degrees. So did you consider using some higher standard equipment? And did you measure the temperature?
Yeah, the temperature of water, right? Of the cooling.
No, the air. So when you open the furnace, the hot air come out, right?
Yeah.
And did you measure that temperature? Because it will affect the pneumatic equipment, because those things can work only maximum temperature of 80 C.
The pneumatic system on the oven door.
Okay. Yes.
You mean the heating air of the mold will affect to the pneumatic system?
because what I see in the system that the whole pneumatics things is on top of the door, right? The latch.
Yeah. Yeah.
So the hot air will come out and affect the system, the equipment.
Yeah. This thing, my team has not the idea about this and not research about the affection of the hot air to the pneumatic system.
Okay, thank you. And just one comment on the report. On page 16, figure 4, can you open the report and show us for the whole committee?
Yeah, wait a minute.
Can you share the screen?
Yeah. This is the report of my team. And what part
page 16.
Page
16.
16. Yeah.
Go up here. So the liquid will become solid by melting process. Is this correct?
Yeah, sure.
Really?
Because before put the mold into the oven, it have to be the liquid, the ink, and after bake it will become solid. But when it's finished in left oven, it become solid, but not perfect solid. It's just rare.
So you put the liquid into your mold and you bake it.
Yeah.
And it's become solid by melting process.
Yes.
And from the solid, when it's become liquid, it will go through cooling process.
No. This is just process of cooling and melting. If it will become a solid, then after the dry oven, it will put under to the water, and at that time is finished the loop, and we start a new loop.
So the thing you saw on the screen is not correct, is it?
Yeah.
I want some comment from the committee for this thing.
Let me explain it a little bit. So the chamber will, both the melting and the cooling process will happen in the chamber, both the process. So it will, in the beginning, it will heat the chamber to a certain temperature to solidify the PVC liquid. After that, it will turn off the heater and let the mold cooling naturally. After that, pull it out. You can pull it out and dip it into the water to finish the whole process.
Okay, thank you.
So it means that in the figure 4, maybe need some modification for exactly with what the process as explained by student. I think so.
Yeah. You cannot turn from the solid plastic into the liquid, right? So yes. The below around is incorrect. Right.
Yeah.
Yeah.
Should be modified. Please take care about this, student.
Yeah. I will modify it.
Of your process, your working process, but maybe it's not exactly right. So therefore need to be revised.
I have some comment on your project. I think one problem with your project is that you inherit the hardware from your senior, right? I think the whole hardware you only showing the controller, the temperature controller, so you may not fully understand the device. That's why in your answer there is some uncertainty, some hesitation. So because you're not sure about what you are doing. And second, your controller, I think the algorithm, the control algorithm is quite simple. And before you design a controller, you need to state the controller requirement. For example, what is the temperature, what is the accuracy you want to achieve, and the settling time, for example. Many things that you need to define before you start to design a controller. In your project, I think it's quite simple. It's quite simple and not very well defined. You should, I think, redefine the project objective and state clearly that what you have made in this project, what you have inherited from your senior. Okay. Any question, Prof?
Yeah, okay. So I have some comment for US thesis. The first one is this is a practical projects, and the proposed products is already applied for the real manufacturing. So I think it's a very good. And the most important thing in this project is the temperature control. You know that. So I read in your report, and you have already defined the BID algorithm, but I don't know why. So why don't you show it in this presentation? So you do not show anything related to a presentation. So I see I have already seen in your report, you have already derived transfer function, and based on that transfer function, you design a controller. But you did not see any, you did not show anything in your presentation. So I think you should do that. So in my opinion, in the experiment result of the temperature control, you should use the graphical design, use a graphical chart to show instead of a table. And I have one question for you guys. Let's present the main methods you are using to find the PID coefficients for the lower and upper oven. Okay, thank you. Do you understand what I mean? So I'm asking you, let's present the main methods you are using to tune the BID coefficient and in the lower and upper oven.
I will answer the question. We use chirL method to define the value of PI, and we use experiment to define the actual value. We adjust value following the chirL.
So I see I have already seen in your report, you use some methods, the chirL methods 1, chirL method 2, or there's some methods. So, but I'm wondering what methods actually you're using in these projects?
So the method you apply in this project is chirL 1, because another method is have the error is very high, and the chirL 1 is have the low error.
Okay, thank you.
Dạ, quý thầy trong hội đồng mình còn có câu hỏi gì nữa không dạ? Dạ, hai bên có câu hỏi gì không thầy Bình ơi?
Không. Dạ,
Okay, then we can move on to the third presentation.
Yeah. Nếu như hội đồng nếu như hội đồng không có câu hỏi gì nữa thì chúng ta sẽ di chuyển qua cái đề tài tiếp theo nha các bạn. Thì cái đề tài tiếp theo mang tên là Implementation and Development of an IIoT Web Application to Monitor Automation Machine and to Enhance Data Insight using Node-RED as Schneider Electric Manufacturing Vietnam. Thì sinh viên thực hiện đề tài gồm có sinh viên Nguyễn Thành Đạt mã số 171460015, sinh viên Lê Văn Nhu 171460047, sinh viên Nguyễn Đình Nhật Tài 171461185. Giáo viên hướng dẫn là thầy thạc sĩ Phạm Bạch Dương. Xin mời các em.
So, good morning everyone. Welcome to Avatar on Group. I would like to present our preparation project, which is implementation and development of an industrial Internet of Things web application to monitor automation machine and to enhance data insight using Node-RED and Schneider Electric Manufacturing Vietnam. Our team has 3 members who used to be intern students at Schneider Electric Manufacturing Vietnam, and our advisor is Mr. Phạm Bạch Dương. The preparation project was sponsored by Mr. Kltn at Schneider Electric Manufacturing Vietnam. So take a look at the agenda. We will have 5 parts in our presentation. The first one is overview. At Schneider Electric Manufacturing Vietnam, they are applying the lean digitalization system for manufacturing process management. On this application, the operator had to manually key in the data into application. There are several modules and functions to support the process, such as the output tracking, the manufacturing time, the downtime reason, operation status, and the undone module as well. For the undone module, we will have some categories like the machine, material, manpower, and so on. The problem here is that the operator can only key in the general issue, which is on the list, such as the issue on the tester, the puncture, history machine. So, you know, a factory will have many machines on the floor. There is nothing on machine error or plumbing for each machine on this application. Whenever the machine is in breakdown, the operator will press the undone button and key in which type of machine. Then the technician will go from the maintenance center to machine cell for troubleshooting. So it's difficult to monitor the machine performance and collect data on machine error or plant frequency for analyzing and taking preventive action. Here is the factory layout at Schneider Electric Manufacturing Vietnam. My hiring manager usually asks me to go to the machine station and check the machine status on there. So I have to go from the office to the machine station, then take a picture on HMI and report to him. I estimate that the distance greater than 40 meters. At SCMV, they have Aviva Insight system, which will take the role at data collection. But there are many issues on this system, such as the data reliability, the data visualization, lack of the people to maintain and develop and so on. Therefore, people did not use the Aviva for monitoring or collecting machine data anymore. This is the reason why we came up with our project here. So based on those problems and issues, we propose the graduation project to hiring manager and define the customer need. The first requirement, we will convert the overall equipment effectiveness monitor Excel file template to our application. The second one, based on the HMI at the machine, we will collect that data and display it on application in real time, such as product reference, the cycle time, and so on. The next one is the requirement of collecting the product defect type. It will check the play at the quality module. And the last one, there are the machine error detected at the machine station. We will collect and display on the machine error to our application as well.
So after 4 months in researching and constantly developing, we will implement and close OpenPoint at the end of July 21. Our first objective is to develop an industrial IoT web application to support monitoring the performance of USB tester machine that's at production line with the scope up to the USB tester T02 machine. Our project could have better results if it was not during to the pandemic situation, because during the COVID-19 situation, it's very frustrating to travel to the factory to validate the data was retrieved correctly or not. So we have put more effort into monitoring it. So the next step is we have the impact and benefit of our project is real-time machine status monitoring, tracking and analyzing equipment values, defect type, support monitoring overall equipment effectiveness, enhance productivities, and remove non-value added to the activities. So as you can see, in the factory, Aviva Insight takes a huge responsibility to collecting data from the many research, and our machine monitoring applications transfer and receive data from Aviva and interact with the rest of department software. The next, let's go to our solutions. The first one. Our monitoring application contains 3 main important parts. This is the place to store data, the place to process business logics, and the place to display business logic. So let's come to our brain of our applications. Node-RED. Node-RED was made by IBM. IBM as a tool to connect any kind of hardware, ABI, or Internet of Things. In technical standpoint, data and front end cannot communicate with each other, so that Node-RED is configured to act as a bridge. We can call it as a backend between the database and monitoring application to talk with each other. So Node-RED has an enormous role in the applications. It retrieves data from the BOC via Modbus TCP to store into database, and after that, they send back the data from the database to the front end. The Vue.js applications is also process a lot of business logic with it, which is calculate OE output, generate CSV file from data. It gives us advantage in checking the raw data and calculating separately without relying on BOC calculate data that could sometimes be wrong. Monitoring application is a web-based applications written on Vue.js. To be quick, Vue.js is a framework of JavaScript that Node-RED can integrate with HTTP protocol. It also generates user interface and user interaction with applications. We are using NIDA database to store data that feed from the BOC and all the data that was sent to the database by the Node-RED module. The database is using SQL, a standard language for accessing and manipulating database. So let's talk about some feature and applications that it has to offer.
First of all, we drew an overall layout and design, what our application should have. And we have decided that the sidebar should have 6 different pages. Real-time monitor, home, OEE monitoring, production, quality, and machine error. After having the permission to dig in the PLC program of the machine, we simply track the input and output data as well as import data to our application database using Node-RED. Finally, this is the final product at Schneider Electric. After sign up or sign in the application from a specific web address, the real-time monitor page will show what's going on at the machine within a 2 seconds interval. This page is the priority for engineers to have a fast insight. On the other hand, the home page will be responsible for taking a closer and deeper look at historical tracking options. On the OEE monitoring page, we can modify the value to find out the most productive and efficient status. The consequence will lead to the production and quality page, which illustrates the comparison of good and non-good products, whether the other one shows which type of product's fault usually occurs. Moreover, these pages have the ability to export data into an Excel file. The last page, Machine Fault, takes the role of helping engineers and technicians easily notice what caused the machine breakdown and fix it ASAP.
So let's talk about some very special pages in the applications, that is a real-time monitoring page. So at the basic level, the Vue.js is only getting new data by requesting through an API. But we want to synchronize the data from the BLC with the data on the applications. That's why we use WebSocket protocols to have two-way communications between front-end and back-end simultaneously with the low latency to update the data in real time. Just keep updating the data every time there's a new data feeding from the BLC so that we can constantly monitor the output of the machine. So we have three generic functions in the applications that almost appear in every page of the applications. There's filtering, visualizing, and exporting. So we custom an alarm function for output parameters like OEE and FPY as first pass U. Whenever these parameters drop below thresholds that we putting out, we send an email to alarm process owner.
Okay, now let's check an achievement. As you can see, that's from the scope of the project. Our project team has included supervisor, have designed for critical evaluation, content objective of an IoT web application, initial expectations, user interface design, and function filters. Yes, as you can see, our project has been evaluated by the project sponsor and the digital transformation leader. We were doing well at the designing user interface, this one and this one, including visual elements, functional elements, and container elements. And our rollback is that the instant notification for alert and warning is still not working as well. So in the next, this is the full commentary of the evaluations I mentioned in the report folders, which we only have the fast look at the feedback. Our web application will have to improve the data analysis using machine learning, algorithm, and artificial intelligence to predict the machine downtime and the best parameters. I can zoom into you. Yes, this is the evaluation and common feedback of the digital transformation leader. So the next one is this letter was evaluated by the manufacturing engineer managers and the project sponsors. The next one is that the application should be applied on most of the machines in the companies, as well as integrated with the lean digitization system. Okay, next step, as I mentioned to above, that's using predictive and predictive analytics. And the second one is integrating to multiple machines and lean digitization system. So the next one, the third one is that upgrade the alert notification filters And the last one is develop the multi-level user access. We also develop the multi-level access. It does preventing the user from declassifying the information. So in the final analysis, this monitor applications bring more value to the SEMV database, and it's supporting the OEE monitoring. On the other hand, the engineer recognize the abnormalities during the operation time. The stakeholders have the fast insight of the machine performance. They have maintenance engineer to improve the preventive maintenance task list. And the last one is help quality engineer to define the most contributing to the product failures. And this is our application release letter. So thank you for listening.
Ở cái câu hỏi của phản biện trên cái nhóm Zalo các bạn nha. Các bạn coi giúp thầy. Đây là câu hỏi của thầy phản biện ha. Rồi bây giờ thầy xin đọc nhận xét của giáo viên phản biện. Thầy xin lướt qua những cái nội dung trên, đọc vào đi thẳng vào cái ý kiến nhận xét. Về thứ nhất, cái kết cấu và cách thức trình bày đồ án tốt nghiệp. Thuyết minh đã được thực hiện có kết cấu và cách thức trình bày tốt. Về nội dung đồ án, đây là đề tài hay, có tính thực tế cao. Khi nhóm sinh viên thực hiện đã có cơ hội để xác định vấn đề thực tế liên quan đến ứng dụng IIoT Web, Industrial Internet of Things Web để giám sát hệ thống máy và thiết bị tự động, cũng như sử dụng Node-RED tại công ty Schneider Electric Manufacturing Việt Nam. Sau đó lên phương án triển khai và áp dụng thực tế và áp dụng theo thực tế sản phẩm tại công ty. Về số 3 là kết quả đạt được. Ứng dụng IIoT Web và Node-RED để giám sát hệ thống máy và thiết bị tự động trong thời gian thực, cải thiện hiệu quả của việc phân tích dữ liệu, chuyển đổi và thành lập mô hình dữ liệu. Về những thiếu sót tồn tại của đề tài, thì nếu có thể bổ sung thêm minh chứng về tính hiệu quả của giải pháp về web IIoT đề xuất tại công ty Schneider Manufacturing Việt Nam sẽ tăng thêm tính thuyết phục của đồ án tốt nghiệp. Về câu hỏi thì giáo viên phản biện đưa ra 3 câu hỏi. Câu hỏi thứ nhất, hãy cho biết tính mới và sáng tạo đã được nhóm sinh viên thực hiện trong đồ án tốt nghiệp. Câu hỏi thứ hai, làm thế nào để đánh giá được chất lượng của việc giám sát hệ thống máy tự động bằng máy tự động. Thầy xin đọc lại. Làm thế nào để đánh giá được chất lượng của việc giám sát hệ thống máy tự động hóa bằng IIoT Web. Và câu số 3, nhóm tác giả có thể xây dựng một hệ thống giám sát iMonitor sử dụng nền tảng IIoT Web cho một công ty công nghệ khi có yêu cầu không? Xin hết. Xin mời nhóm.
So can we have around 2 or 3 minutes to discuss around on the question?
I think it should be 1 minute. It should be too long.
Okay, okay, sir.
Okay, so we are ready.
Okay.
Okay, so based on the project, we follow the facility from Aviva Insight System as Schneider Electric. As I mentioned in the first presentation, the Aviva Insight System at Schneider Electric manufacturing in Vietnam is not effectively. So the hiring manager requests us to make the IoT monitoring machine. So I would like to share some picture or video about the Aviva Insight System as Schneider Electric manufacturing in Vietnam to compare our product and the Aviva Insight currently. Okay, so the first one. We take a look at the Aviva Insight. So the Aviva Insight just displays some basic parameter on like this, the good and bad, and some parameters is not correctly at the machine station. The next one is for a long time, people at Schneider Electric didn't use Aviva Insight System anymore due to the poor on the data visualization, also the data reliability. So as you can see, some user active 1 year ago. The next one is the Aviva Insight System just displays some the chart, so the user cannot custom the chart like the goal chart, the Pareto chart, or the some table. This is the equipment efficiency model, but Aviva Insight have those function, but they didn't use it anymore because they lack of the people to maintain or develop some programming on that platform. This is the active user. Because our team already joined to got the official job on another company, so we cannot access to the system as Schneider Electric anymore. I just record some video review about Aviva Insight System to get you guys clear about the Aviva Insight System and compare to our application. Here's some basic data, the parameter on the application, but some parameter is not correctly. So to answer for this question, for the first question on the innovation, we take a comparison directly to the Aviva Insight. For the second one, how to evaluate the quality of IoT application. So on this question, we would like to present the real-time monitoring. It takes around 2 seconds to update the data from the machine to our application. So we take a look at the second from 12 to 14. Here. This is the 12. Then the value at the HMI is 14. And then 14, our application already update the data on here, 14. The first one is the real-time monitoring around 2 seconds. The second one, I would like to share the OEE monitoring template. Based on the OEE monitoring template that hiring manager provide to us, we convert the template to our application. On this template, we have some formula to calculate the OEE as well. like the availability, the performance, the quality, and overall equipment. So based on that formula and template, we convert to our application. So the data reliability is confidently. And also evaluate by hiring manager. You can see on the evaluation report. So our team will continue to answer the question number 3.
So let me take a look at the number 3. Is to review the monitoring applications on the other company ask. So we can definitely make a new version of this application to and then migrate into the other company to use it directly without hesitating because Node-RED and Vue.js is a very flexible platform to developing in, and it could even have more of headroom for us to expanding the applications and scaling up the application. So definitely, yes, we could migrate the applications to other company. Yeah, that's my answer.
I want to add some information in the question 1 and question 2. I will share my screen. Okay, it's my screen. We have some backup slides that we want to show you. This is some, the questions is that the new and the more developed from the old one to our application is that it saves time and the effort to monitor the OEE parameter while checking the machine status at the production line. Because you know that we have to work from the office to the production line. It's over 40 meters. It takes about 5 minutes, yes. And the real-time machine monitoring and the data visualization. Our data visualization is the component of the visual elements, from the color to the typography and the container elements and the elemental and the functional elements. Moreover, our application can export the data from the report directly, and in the old one, the API inside, it cannot export the data into CSV files or something like that. So it's kind of hard to recheck that file and organize. And one thing more is that wait, sorry. It can support the maintenance on preventing the unplanned downtime. Okay, this is our filter. Yes.
For this point, support the maintenance based on the machine error of machine error collected data. We will define the critical. Based on the machine error, we will define critical station that happen error commonly. So we will support the maintenance to build up the maintenance checklist, the maintenance checklist to focus on those stations that happen many alarm. And for the defect type, we will collect that some common defect type on the product. So the quality engineer will focus on the most contributing to the defect, and then they will take the action to prevent those defect type on product.
Yes, as you can see here, it has the USB tester header. Can you show me the parameter of the USB header?
The USB header here being broken due to the warming on the USB header. So whenever the machine being wrecked out, the most common wrecked out reason is the worm out in the USB header. So you see the USB header being worm out, so the matching with the product is not efficiency. So the measurement value returned to the measurement value is sometimes not correctly. And around for When the maintenance check out the USB header and replace, it check around 30 minutes to 55 minutes to release the machine back to the production. So this is the major downtime reason on the USB tester machine. So our application will collect those data and support the maintenance on those tasks to prevent the breakdown happen.
Okay, so I think that's all our answers. Thank you.
Thank you. Thank you for the answers. Do you have any question, Prof?
Các thầy khác có hỏi gì không ạ?
Okay. I have a question. What is the OEE parameter? Do you know?
So I would like to answer this question. The OEE stands for the overall equipment effectiveness. It's the KPI to measure the efficiency of the machine. It was calculated by 3 key parameters. The first one is the availability. The second one is the APQ, is the performance, and the last one is Q, is quality. So it's measured by 3 key parameters.
Okay, thank you. And another small question. What is the difference between your work compared to another company? I remember the machine, the RONET, you know, RONET machine.
Sorry, RONET?
RONET. That's the international corporation, and they manage or they provide
right?
system. RONET, KHÓA. And that system has provide everything you show in your work. I don't know, before you do this project, you already referred about that system.
No, let me answer on this. So sir, we did not have any look at Chronex as you talk, because in Schneider there already a system that use Node-RED. So I just developing the application based on what Schneider has been using, but not using the but not look at anything else. This is we did not look over the Chronex as you say. Yeah.
Okay, thank you.
I have some opinion on your presentation. I think it's very well prepared, and the pronunciation is very good. It's quite enjoyable to listen to your presentations. But there is few problems. First, why you choose red note? Not red. You mentioned a lot about the benefits of broadness, the advantages of Node-RED, but what is the limitation of Node-RED?
Can I a few moments to think about this, because Node-RED is a very well, let's say Node-RED is a very complex complex platform. Yeah. It's not used. It's not easy to use. It can be used for the other user, but it's very hard to understand all the application in it, because there's a lot of pre-built in a module that we have to dig very deep in the code to understand all of those modules and remodify those. So I think to be to use the Node-RED is very complicated to understand all the pre-built in the module for the developer.
Yeah, I agree with you. There are many pre-built functions inside Node-RED, right? That's why you choose Node-RED, right? But do you fully understand what you have done? For example, what is the protocol that you use to send the data from the devices to the server? What is the protocol?
From the device to the server is we using the HTTP request, sir.
No, I don't think so.
Because yes, Node-RED has a function, a built-in functions that could actually accepting the HTTP request like get and post from the Vue.js. I'm using Axos for Ajax core that's sending HTTP request to the Node-RED. So it's actually accepting the request, and also Node-RED is using WebSocket by default, and because Vue.js is not in a separate server, so we built in Vue.js inside as a module, as a whole module inside Node-RED, so it communicate by WebSocket directly in two ways. So that is very comprehensive for us to use now.
Yeah, but HTTP is not a suitable protocol for the large system because it's quite slow. Why don't you use MQTT, for example?
MQ. I know about that MQTT protocol. Firstly, I think it's better to because our server has limitations in hardware, so maybe using HTTP to preventing the load from the server too big, that could might broke down the server, and HTTP has some very advantage in this application because we have to wait for the server to recall back to respond to the request from the web. So that I think is more efficient to use in that way.
No, my opinion is totally different. MQTT much more simple and much more lightweight than HTTP. So you cannot say that HTTP is suitable for the limited capacity hardware. No, MQTT is much more suitable because it's lightweight and it's much faster and much more simple. And I think it's the file of the IBM protocol. It's created by the IBM, so it's integrated into the Node-RED. So there's no reason that you don't use MQTT.
Okay. That is some mistakes from my research. Yeah.
I think your project is quite nice. You build a very I think attractive monitoring tools, and you can visualize the data. I think quite nice. But I think for an engineering is okay. But I would like to see some scientific contribution in your project, because what you have done is mostly to drag and drop the preview tool, right? Drag and drop.
No, sir. We did have used some drag and drop flow function, but almost every functions in our applications that I have to written myself, and I have to create my own flow to work with the other flow. We not just drag and drop.
Programming language that you use?
I'm using JavaScript for those. To be precise, Node-RED is built in Node.js, so I'm using JavaScript to pre-build every other functionality node, and very dedicated to the function, so it could work very well.
So do you program the device? Do you define how the device send the data through the signal, or you can
we make use of the facility from the IoT Xbox that the project sponsor provide to us, and we also refer to the document. Is it the document from Schneider Electric, including the Node-RED for IoT monitoring. We refer on this document.
Okay, okay. So it's already defined, already programmed, right? By other people, right? By the company.
Is the IoT box or hardware is combined on a Node-RED module, and we match up those facility and we programming and develop our application.
So it makes your job much more easier, right? Much more easy.
Somehow is very delightful to actually develop in already built in facilities. Yes.
So I have some comment for your thesis. The first thing I think I would like to say is congratulations, you guys. This is a great job. And
you, sir.
You guys also understand the process, working process of the factory through this research. So, but there are some terminology. So I think some terminology and some abbreviation, I think you need to interpret before you report. Such as the IoT, OEE, Node-RED, or something like that. You need to talk, you need to interpret before you report. It will be better. It will make the listener good understanding what you are working on, right? So, okay, so that's something I commend for your thesis. Thank you, committee member. Thank you, student.
Yeah, thank you for your comment.
Thank you, sir.
Okay, if there are no more questions, then we can move on to the next project.